Hello everyone, good evening.
Good evening.
Am I audible? Oh yeah, thank you. I hope everyone is charged up for this project session. That's gonna use whatever you have learned so far in your statistics course or ML course or basic EDA. So it's gonna include so many things all together. And I guess I have met some of you guys during the mentorship sessions. So yeah, so I know a great batch and great people, motivated people. So I expect lots of questions from you guys. And as you all know, it's a guided project session. So it's not gonna me who's gonna drive this. So you are gonna come up with your thoughts, your ideas, your intuitions, your approaches, right? So you're gonna come up with some answers, then we'll discuss them, and then we'll go forward. Okay. So let's keep this session very engaging. Wherever you have any thought, right, wrong, anything. So you can, if there is not much noise from your end, you can keep yourself unmuted. You can ask, you can put your questions over chat, right? So do engage during this session. Okay. Don't just listen. This is for active participation. This is not a normal lecture. So your active participation is very much needed here. So yeah, let's start this session. If you guys are all in. Just a second. So I should know the participants and their chats. Okay. So I hope everyone has this problem statement, right? Is that the right assumption? Guys, do let me know over chat, or you can unmute yourself and then. No? Okay.
Sorry, Paras, we don't have the access of this file right now.
Okay. Okay then.
Maybe
Yeah.
you can share the link with us in the chat so we can follow.
Okay. So let's first understand the problem, right? Then maybe I can share it with you meanwhile. Okay.
Sure.
Yeah. So let's start our guided project session. So as you all know, like so far you must have come across like data science is not just Python, right? So Python is a tool kit that helps us to solve our business problems through different algorithms, through different analysis, through different statistics, through maybe through simply through EDA also sometimes, right? So now in this session we are going to learn how we provide a solution to a problem through whatever we have learned so far in this particular courses, right? In the last few courses, or stats ML or Python code, Python, right? So I'll just give few seconds for you to read this problem statement, and then we'll explain, then we'll discuss. Okay. So I hope all of you are able to see my screen. Okay. Okay, so please go through this problem statement, then we'll discuss, get an idea. Yeah, so there is a Chinese automobile company, Geely, that aspires to enter the US market by setting up their manufacturing unit there and producing cars locally to give competition to their US and European counterparts. Right. So there's a Chinese automobile company, and that is venturing up to start a car manufacturing unit in US, but uh, the car and its pricing depends from area to area, right? From state to state, from country to country, right? And Chinese company Geely doesn't have any exposure so far to the US market. So what they're trying to understand is how the pricing of cars in US. Yeah, Sumant, I'll share that, because this link you won't have access. I'll share that link. Or maybe I'll share it, this one only. But don't start editing up here itself. But don't start editing here itself. So share with.
No, we'll actually copy that and we'll try to follow with you.
Yeah, please. Yeah. So I hope you are able to access that. If not, let me know.
Yeah, we can access this. Give us a minute to make a
Okay.
copy in our drive.
Yeah. And you can download the data from here. I've shared the link. Cool. Can you download the file? Can everyone please check? Rajat says he's not able to access the file. Is it so? Uh, is everyone able to download the file?
Yeah.
Data
We
file?
are able to download that file.
Okay, Rajat, I think, I don't know what's the issue on your end.
Hello. I can
Yes.
I can access the collab notebook also. Like it's
Yeah.
getting me error.
So you can't access that collab notebook.
Collab. Yeah.
Are you copying it properly? Because rest are I think able to copy that, see that collab notebook.
Yes, I'm doing it properly, I guess.
Anyone else having issue with collab notebook? Okay, so Nurul also has issue. Oh, Shivam also has. So this is not a small issue. Okay, let me, don't ignore the last message. I'm copying it again and then posting it. I think those who have attended as panelists, they are able to. Sorry, those who attend as attendees, they are not able to. Is it like that? No. I'm copying it again. So there is one more link shared with you. So you can download it from Nilgiri course materials. Is everyone able to access both data and collab notebook? Either through the AlmaBetter course materials or through the shared link. Okay, Nurul, thank you. Thanks, Sanchita. Okay, coming back to the problem statement, let's start now, I think. Okay, I'm assuming everyone is able to get access both the things. Okay. So this Chinese company Geely wants to enter into the US market, but they do not know how pricing behaves there, right? So what they're trying to do is they're trying to create a model based upon the present data that they have of different cars and different properties of the cars and the price at which they were sold, right? So we have this data with us that tells us all the car related properties as well as the car price, right? So now we have to come up with a model so that that model helps us to solve a business problem, and that business problem is to get the optimum price for the cars that the Chinese company Geely will be manufacturing in US. Okay, so there are different variables that will be impacting the price of the call, right? So now we have to identify what all vectors will impact and what is their weightage, how will they impact. First of all, a quick question to all of you, and you can answer that through the Padlet link that I'm going to share with you guys. Let's try to post your answers here. So my question is, so now you understand the problem statement. We have to come up with a model to get the price of the cars with available independent variables, right? And this will be used by the business people so that they can tune the right variables to come up with the optimum price, right? And they can decide further business strategy and price levels and everything, right? So basically, to understand how this pricing dynamics is working in that market. Now, on the face of it, what does this problem look like? Is this a regression problem or a classification problem? You can post your answers in this Padlet link. Yeah, it's a regression problem. Why? Because the dependent variable, right? Our dependent variable is a numerical variable. It's not a categorical variable. Price is a numerical variable. It is a continuous variable that we have to predict. So that's why it's a regression problem. It's not a classification problem, right? Now, first of all, first we'll see the data, right? What kind of variables that we have been provided with, and how we can play around with it, how we can do ED on it, how we can deal with different kinds of variables. With different kinds, what I mean is continuous and categorical variables, right? So before coming up with any approach or any solution, let's first try to load the data and see what the data contains. Okay. Yeah, so most of you have given the right answer. I think all of you have given the right answer. Regression, right? It's a regression problem. No doubt on that. And no one should have a doubt here. Right. So this is, I'll start. So basically first we'll load the data and then we'll come up with right kinds of approaches to go further. So loading all the required libraries, right? NumPy, Pandas, and different sklearn. Why sklearn? Because all this linear regression that you have studied in the past week or so. So all these functions are already implemented in as part of sklearn library. So we'll be using sklearn with different functions, and Cbond for, as you all know, plotting, right? Matplotlib for plotting, and this is to ignore the warnings. And this is mounting the data. So I mounted my Google Drive to my Google Notebook. Now I have to read the data. So you guys might have to change this link, right? Wherever your data is there, you need to change this link and get the right URL to load the data, right? So for me, this is the link. So I'm loading the data set, and I hope no one is just listening to me or seeing the screen. Everyone is doing hands-on, is loading the data. And whatever steps that we'll be running here, please try to run on your own in your notebooks. Okay. So going ahead. So let's have the first look at our data set, what this data contains. So it has car ID, symboling, car name, fuel type, aspiration, different columns it has, right? And we'll go through them and see what all these columns mean. With dataset in next is dataset info, right? With dataset info, we'll get an understanding of different columns, right? Without so basically dataset info gives us a complete complete snapshot of our data, right? Whether it has null values or not, what is the row size, what is the column size, how many columns are there, how many rows are there, what are the data types, right? So all such info gives us a complete snapshot. So now, based upon this dataset info, what do you think? How many rows we have and how many columns we have? So yeah, so 205 rows and 26 columns. And how many null values? Yes. Yes. So 205 rows. So 205 rows and 26 column we have, right? So we don't have a very big data set. So we have just 205 rows. So basically 205 cars and their properties and their price in 26 columns and without any null values, right? And let's quickly go glance through each of these columns. What do they mean, right? So first column is car ID. So that's a unique ID that is given to each observation. That's an observation ID. Next is symboling. That's something related to insurance, whether that how much will you rate, right? On insurance, for insurance, how much will you rate that car, right? So if that car is very risky, it's +3. If it's pretty safe, it's -3. Next, car name of car company, right? Fuel type, aspirations. There are some domain specific car terminologies, right? Car body, drive wheel, engine location, wheelbase. right? So there are a couple of them, right? And as we will do the EDA, we'll go through each of these columns and see what do these columns have, right? But some are very clear, right? Car length, car width, sorry, uh, engine type, engine size, fuel systems, right? So all these properties decide the price of the car, right? And we don't know how much, how important is each of these properties, or maybe some properties of the car are not even important to us, right? So first we have to rule out all such properties which do not car properties or car features that are not that do not impact the price of the car, and then we'll start modeling, right? So we have a set of independent variables, and what's our dependent variable? Guys, what's our dependent variable? I think I should be able to delete it. Yes, price is dependent variable, right? I think many of this, I'm not able to clear this up. Uh, okay.
Just entered the code.
Oh, sorry. Yeah, thank you. So yeah, so we have all these columns, and as most of you or all of you mentioned, so price is our dependent variable, and there are a couple of 25 um, independent variables that we'll be working on, right? So one variable, can you tell me one variable out of all these variables that is outright rejected, right? One column name that is has to be rejected straight away, right? There is no analysis needs to be done for that. Right. So yeah, car ID is the answer. So car ID is something that is an observational ID, right? That is an ID to that particular row that will not impact our price dynamics, right? So we can, in our analysis, that is for sure that car ID can be removed straight away. But out of the remaining 24 columns, 24 independent columns, what all needs to be removed or what all needs to be merged, that we'll get to know. Okay, so these are the columns. Now, first step for, what do you think? You tell me what is the first step, right? After getting this information, what should you look for in your data? What do you see? So you have the data, you know the columns. Now, what is the next step should be? Descriptive, okay. Each feature types, okay. But feature types we have already seen in the info, right? So we saw which all columns are categorical and numerical. So someone, yeah, descriptive statistics, categorical and numerical. EDA करेंगे अब, okay. Need to find out what, Nurul. Okay, so next step should be to understand the distribution of data, right? We have to understand through the distribution of data either through description function or through different plots, right? The basic funda is to understand the data distribution, right? Data distribution of our dependent variable also and our independent variables also, right? So first step we'll do is we'll understand the data distribution. Now, if you guys are following me up till here and you're running these things in your notebook, so you can see that we have data distribution for data distribution description for my complete data set for my all columns, right? And you see two different kinds of things here, right? Some of the values are nan. Can you tell me why these are nan? Categorical data. Yes, they are categorical data. Right. So if I had not put include is equal to all here, so it would have given me what? It would have given you numerical or categorical.
Give numerical.
Yes, so it would have given me only numerical data if I had not put include is equal to all, right? So these are, I think, basic things that you all must be aware of going forward. So if you see the data now, for my car ID, it doesn't make sense, right? I could remove it before also, but I'll be removing it afterwards. So now symbolic, right? Symbolic is my, based upon the data that is given to me, it's my numerical data, and its mean, standard, minimum, and median, everything is given to me, right? But you won't be able to understand that much with this data as you will be able to understand with the different plots, right? So what we'll do, we'll try to see the different plots. Here we can understand min max, right? How this particular values vary. And can you tell me anything, any specific or any one information, one insight that is getting that you are getting from this table regarding the data distribution? One specific insight. One specific insight. If you see the mean and 50%, what is 50%? Like, you guys can keep yourself unmuted if you want, if there is no so much
Yeah,
noise.
50% is the median.
Right, so it's median. So if my mean and median are very close, what does it mean?
Normal distribution.
Always normal.
Normal distribution, right? And for any algorithms to work properly, right, that is a basic assumption that we take, right? Our data distribution is normal or should be as close to normal as possible. If our distributions are skewed, that means we have to do something about that, right? So we'll see now what all we can do to remove the skewness of our data, right? So now first next thing to understand is if there are any duplications in our data, and if you run this there are no duplications, right? What does it mean? Out of all the 205 rows, I think 205 rows or 206, 205 rows. So 205 rows, there are no duplications. Every row is unique, right? Next comes is different columns you can access like this, right? Now next is explorative data analysis. Now you tell me, what should I do now? What I should be doing now?
I think
We
we
have
should
to
plot the
remove.
distributions of the variables.
We need to check the distribution of different variables.
Univariate and bivariate analysis.
Okay, yes, enumerated biometric analysis. What else?
We can remove that unnecessary columns like car ID and car name.
Car ID and car name. Okay. But do we need to remove car name?
Yeah, we can remove.
No,
I think there is no need to remove the car name.
no, there's no need to remove car name. Like,
And if you see the data of car name, where is that? So we had put this data head, right? So car name is our car name, right? So we'll see when we'll go to each of these columns one by one, and we'll see what can we do for the car name, right? So let's try to do some EDA, right? And first of all, what EDA for what variable we should be doing? Which variable we should be doing EDA for first of all?
Dependent.
Dependent variable, right? So we'll do an EDA for the dependent variable, and that should. This is the EDA. Is that size okay for all of you?
You can make the size small, maybe 7 around. It's 15 and 10. It's too large in Colab actually.
Right. So what do you think? What does this distribution tell you? Is it right skewed, left skewed, or normal distribution?
Yeah, I think it's right. Cute.
Positively skewed, yes.
Yeah.
Positively skewed, right? So what is the solution for this?
Log transformation we
Log
can
trans.
apply.
Yeah. Log.
Log transformation, right? So you know that, right? When do we do square root transformations or log transformation or inverse transformations, right? When do we do inverse transformations? Anyone? When do we do inverse transformations?
When it is, I think, highly rightly
Right,
skewed.
right. It's when it's highly rightly skewed, then it is. When it basically it's highly positive skewed, then it is. Then we go for inverse. When it is moderately skewed, then we go for log 10 or log any any base, and then if it is very lightly skewed, then we go for square root, right? And by the functions, right? That is, I think, out of the scope of this session. If you understand the graphs of these two functions, 1 by x, that is inverse, or log x, or square root of x, we'll understand why we do so, right? So just draw the 3 graphs at your home, and then just try to understand why positively skewed distributions are helped with these 3 transformations. Okay, so now I'll do one transformation, that is a log 10 transformation. Right, if you see now, right, what's the difference now? If you see your this x-axis, right, earlier we had the difference was 2000 this 20,000 5,000 50,000, right? What happens? What does log function do? So log function basically, as the values increase, it decreases the space between them, right? It decreases the distance between them, right? So see, here difference is 4.4.2 and 4.8, right? But here the distance is 20,000 and 50,000, right? So now we'll have more of the values or more of the data samples for our dependent variable coming up as part of our normal distribution, right? Does that make sense, all of you?
Yeah.
Right? So Yeah, do let me know if it is very fast, going very fast or very slow, right? It's either it shouldn't be neither too fast or not too slow. You won't be able to finish off this then.
No, it's okay.
It's okay. You can just give us a minute to, write the code and perform, follow
Okay.
along. Yes.
So next thing is what we'll do. We'll take the numeric features and we'll go to all these features one by one. Right. First, we'll take and try to understand. This zooms me a little bit. Okay. Is it fine, Shivam, now? Or Shubhal? Sorry.
I think it's not that much normal. Like the distribution is still like right skewed.
Right. It's not that much normal, but yeah. So it's close to normal. Right. You cannot get what you saw, that's the actual normal distribution, standard distribution that you get, that you see. You won't sorry, you won't be able to get, but it's close to normal distribution.
Could I try inverse transformation here?
Yeah, you can try that. Function called inverse. We can get reciprocal. Okay. See, this is what happens when we go for. So it tries to create two distributions, two different distributions, right? Two peaks, right? So I think that is our log 10 is the better option to take. Okay, so next we'll go to this numeric features and try to plot each of them and see what happens to each of these features. Okay. And this plotting, so plotting really helps us. We are able to see too much of information, like or the requirement of information at a glance level or a snapshot level, and it is helps us to take decisions or good decisions, right? Otherwise it's very difficult, right? Here you had just 205 rows, right? But if your rows are too many, it literally becomes very difficult to scan through the CSV or data frame, right? So plotting is something that is really helpful. That's why it's every EDA is done by through different plots. Okay. Now if you run this, so what I'm doing here is I'm taking the numerical features. Okay. I have numerical features. Now I'm plotting each of this numerical feature with the help of matplotlib. Okay. Now we'll go to each of this graph and see what that graph has. And keep in mind, this is only for numerical features. Okay, so first column is symbolic, and symbolic is something related to insurance, right? Symbolic tells us whether from the insurance perspective that particular car is risky or not risky, right? So it has values from what to what? -2 to 3, right? So my question to all of you now, as you are able to see, it's normally distributed only, right? Or close to normal distribution. Now, should it come under symbolic? Sorry, categorical column or numerical column? Since I can see 6 different categories here, should it be categorical or numerical? and as per our numeric features list, it is coming under numerical feature. Is it right to consider this is in categorical or numerical?
We have to consider it as categorical,
Why
because
categorical?
sometimes in the data we got already encoded categorical variables.
Here, I think numerical should be better because there is a
Can you see this
nominal
value?
feature.
Can you see this value? What is this?
Yes.
0, -1 and -2, right? Does it tell you something? Or the definition of symbolic, right? What the definition of symbolic? Symbolic is something related to insurance, risk level, right? If something is something has been rated as 3, that means it's less risky. Something is I think 3 is very risky, or -2 is less risky. So still, do you think that it should come under categorical? When we say any column is categorical, do they have any relation, these two categories? Yeah, Priyanshi is saying discrete numerical, right? So you see some negative values there, right? And these 6 categories, they convey a level of risk, right? Like they convey a level of risk that increases as we go from -2 to 3, right? So in categories, in categorical objects or in categorical columns, your different categories do not convey any meaning when you go from one category to another category, right? For example, there are 29 states in our country. States can be taken as categorical variable because if we go from Kashmir to Delhi and then Delhi to Mumbai, so these names do not convey any meaning to you, right? These different names, but these different values convey meaning to you, right? Do you get my point?
Yes, yes.
Right. So -2 means very less. I think let's see what's definition again. So symbolic is +3 means auto is risky. So positive means risky. So as we go from -2 to 3, our risk level increases, right? But if we keep all of them as categories, right, then we will be losing out on that information. That risk increases from -2 to 3. Is it clear to everyone?
Yes.
Let me know over chat if it's not clear, or even if it's clear, let me know.
Yeah, yeah.
Okay, so these things we have to keep in mind, right? What is categorical and what is numerical, and many times these numbers misguide you, right? So you have to you have to take into account the domain or the definition of the column and the range of the column, right? And not just go by the numbers and that will create or not just go by the discrete count, right? So it is a numerical column with 6 values, right? Next is wheelbase. So wheelbase is somewhere, right? Some skewness you can find in wheelbase, right? Next is car length. So again, it looks like numerical normally distributed, right? And again, car width similarly. Then car height we have plotted, right? And this plots, what do they tell you? This tell me that what is the frequency of getting car width as 66, 67, right? Or 66 to 68, right? So we have the highest frequency of car width being around 66, right? That's what this plots tell me. Now car height and then curve weight and engine size. So engine size is again very skewed, right? So you will have to do something about it. Again, bore ratio. If this particular value would not have been there, 3.7 wala, right? You could say something that it's fine, but there are values around 3.6 and that are 25, right? It's not just one or two. Next is stroke, right? Again, stroke could be normal distribution except this particular value. All right, then compression ratio, it's either very low or very high. There are no values in between. And for horsepower, it goes from 50 to 300, and then for peak RPM, the values are very distinct or discrete, right? And then city mileage and highway mileage, and then price. So price, we know that it was skewed, and we did a transformation on price to get the log of that price. Okay. So now you got an understanding that, yeah, so these are my columns, right? That these are all numerical columns, and that's how they look. So what's the first column that you think that that comes to your mind, and then you want to operate on that? Yeah, so what I'll do is I will create a doc, and I can
Give us the access for that doc.
yeah, I'm creating the doc. So that was getting logged in to my company ID. So I won't be able to create an open access for that. Yeah. So
Hello, Paras.
yeah.
Can we create a scatter plot like here instead of his plot like?
You can create, but I'll tell you why we cannot or why we shouldn't. Just a second.
Okay.
Share that. Yeah. So I can share this link with you. Let me know if you're able to access it. Should be able to see the doc, right? Guys, are you able to see the doc? Access the doc?
There is no code, I guess.
Yeah, there's no code. I'm putting that code. Right, so here's a floating code. Okay, so now what the point that I was making here, since most of them do seem to be skewed, right? So what we'll do, we'll apply that log transformation to all of these columns, right? So what I'll do is that the way I have plotted here, so what I will do, I'll create another set of plots with this log transformation. Two more things. So if you see now, what I've done is I've done a transformation on all these columns. Same log transformation because I could see the skewness, positive skewness in most of the columns. So what I've done a log transformation and try to bring them normally distributed. Okay, so some of them will not be normally distributed, right? So there's no way we can do that, right? At least for now. So what we'll do that we'll see the further aspects of it, right? Maybe that can those particular columns can be ignored in our correlation analysis or multi-collinearity analysis, right?
So Paras, so I have a question like if a column is already distributed in normal manner, so if we again apply a log transformation on, then what will happen?
So nothing will change much there,
Okay, okay.
right? Nothing will change much there. So you can try it. You can try it just changing some few things here, variable names here. You can try that. Okay. Yeah. So after this, so for numerical features, we have done this. Now, what should we do? So now we should try to understand the relation of all these features, right? And that some of you are calling that univariate analysis by bivariate analysis, right? So what we'll do, we'll try to understand how through graphs, how these particular columns change or impact our prices, right? How these particular columns or different columns that we have seen and done that log transformation, so how do they impact our prices, right? So we'll try to understand that. And is there something other logical step that you guys think that we should be doing before that? Please do let me know. Is everyone able to follow me?
Yes.
Yeah. Okay. So what I'll do is I'll plot that graph. Now you tell me, right? We'll go to each of these graphs. So first is price versus symbolic. Do you find any relation with this? Does symbolic ratings impact the prices? Does symbolic rating impact the prices?
No.
Not clearly
Not
here.
that much.
Right. And why do you say so?
Since it's a categorical and there is no clear pattern here, like there's no
The
current.
slope is done.
Because right, if you see here, as my symbolic value changes from -2 to -2 to 3, you see even 3 has all the values, right? Low to high, right? Similarly, 1 has all the values from 1 to low to high, right? Similarly, -2, -1 all have low to high. You cannot create a relation, or you cannot clearly say that as your symbolic increases, your price increases or price decreases, right? You cannot clearly say that. That's why. And if you see the correlation value also, the number here, it's 0.07. That means minus 0. That means it's very like negligible negative correlation is there, right? And that is clearly visible with this red line, right? Now, if you go to the wheelbase, so with wheelbase, do you see any relation?
Yes.
Yeah.
Yeah, because you see a relation, right?
Yeah.
As wheelbase does impact our prices. Next comes car length. So similarly, car length. As your car length increases, it prices increase, right? And you might be saying that we can see that some prices are here also. So yeah, so not we do have some outliers. So that's what we go for linear regression. I've already shared, Sumanta. Right? I've already shared.
Yeah, got it.
Yeah. So next is price versus car width. Same again, there is a relation. Car length also has a relation, car width also has a relation. Then car height, not much relation is there, right? And you might be able to understand also that based upon your knowledge of cars or your basic common sense that yes, car height, if car height is too much, or car length or car width is too much, prices will increase, right? So that's what this information of 205 observations tell you. Next comes engine size. Again, same. You can see the bore ratio, similar kind of stroke, not that much correlation, right? And why we are doing this analysis with price? Anyone? Why
Dependent
we are,
variable.
yeah, so price is a dependent variable. Okay, so we have different independent variables, and we're trying to different independent variables that are numeric. We're trying to understand their impact on the price values of the cars, right? So for horsepower, similarly, peak RPM, slightly negative correlation, but not that much. Then price with city mileage, right? So if the car has a very high city mileage, or then its price is somewhat low, right? And similarly highway mileage, right? Now with this analysis, one thing is clear that there are some columns that do not impact us so much, right? Do not impact us as in impact the dependent variable, but there are columns that impact heavily, right? Now one question is still to be explored. Can you tell me what question that after this analysis, what should we explore, right? We know that car height also, sorry, not car height, car width also depends, price also depends on car width, as well as price depends on car length. We know that. So can you, what does it tell you? Any thoughts on that? We have car weight, sorry, car width and car length, right? So both of these graphs are, they have positive slope, right? That line has a positive slope. Now, one thing is clear, car length impacts on price, and sorry, price is impacted by car length, and price is always impacted by car width also. Now, what's the next step? What should be the next step?
Yeah, we need to remove multi-collinearity.
We have to first check, right, whether there is a
Yeah.
correlation
Between them.
between what? Between which of
Car
these
Car
width
width
variables?
and car length.
Not like that.
Independent variables.
Yes, between independent variables, do we have any correlation or not? Right, we should be checking that up, right? Because car length and car width both are having the similar graph. That means both are impacting, but it might be the case that these two are interlinked with each other. As we increase the width, our length is also increased, right? And that leads to increase in prices, right? So maybe the cause, the cause is car width only, right? And we are unnecessarily taking the car length also. Is it my point clear?
Yeah, but here we have the domain knowledge, so we said that. but
Right.
we need to check the correlation matrix for that. right?
Yes, yes, yeah, it's rightly said. So we have the domain knowledge, so we can make some inference out of this. But obviously, we'll have to draw the correlation graphs and heat maps to understand how these things are working, right? So what's next step? What I'll be doing is I'll be getting this correlation graphs. So this is our correlation graph. So any observations you have after looking at this graph? You must be able to understand a couple of things from this particular graph. What are those?
Correlation.
A correlation of what? Like correlation between what and what?
Like there are a lot of
Correlation between each feature present in the data set. Like.
Right. Yeah. Yeah. So correlation is there, right? That's a correlation graph. So it will tell us correlations between different dependent variables. But what is coming out clearly from this particular graph, from this graph? Any insights from this graph, right? That was whatever you're telling is actually a function of this graph, right? What insights or what inferences can you draw from this graph? How do we interpret this graph? Or what conclusions I can draw from this graph, from this particular heat map?
like a
Have you guys seen these
positive.
graphs earlier? Seen this heat map earlier?
Yeah, like
Yeah.
we
Yeah,
can,
So then it should be able. You should be able to.
yeah, like the
Ex-
numbers that are close to 1 are highly positively
Correlated.
correlated and
Yes.
negative.
Yes, numbers which are
-1 are negatively correlated.
yes. So what I've done is I have used absolute here. That means I'm not bothered about positive correlation, negative correlation. What I'm bothered about is just the correlation, right? So that doesn't matter to me at this point of time whether it's a positive correlation or negative correlation. What I'm bothered about is whether correlation is there or not. And as the values goes toward 1, that means correlation is high. So what all correlations are high?
Our length and curve weight, I guess. 0.88.
Your length and length and weight.
We are focusing on only the last price, so it will be car height. So no, car height, curve weight is there, engine size is there, peak RPM.
Okay.
Yeah.
City mileage and highway mileage.
But with this analysis, so your car width also is saying, and car length is also saying that I depend on price depends on me, right? Car length, car width also says that. So is it worthwhile to take both of them? If you see car length and car width,
So
right?
yeah,
Car length and car,
0.28.
so what's their correlation?
0.28.
0.84.
0.84. 0.28. Why 0.28? This is the value, right? 0.84.
Yeah, 0.84.
That means it's heavy correlated. That means whatever the information that you can get from car length, you can easily get from car width also.
And also curve weight also.
There is car weight.
Curve weight, I guess it's something like 0.88. You can see like right after 0.84.
Right, curve weight, right?
Yeah, curve weight.
Curve weight.
So Paras, could we remove stroke and compression ratio while predicting the price, as they are very less like
Yes.
predicting the price? Yeah, only the correlation is coming 0.079 and 0.068.
Right, right. So these are some small decisions, right? Some might lead to loss of data. Some might help you further, right? So you have to take some decisions. One decision that is stroke is not that great, right? We can remove that variable. right? And some of you can try with removing that variable. Some of you can just get along with this, like take along this variable and try what impact does it create, right? So now first thing is we have to reduce this the set of dependent variables that we have, right? Can I do something for car length and car width?
You can multiply.
You can add them.
You can multiply.
Card link.
I think
I
we
should
could
add them or
do
multiply them.
Multiply length and width.
Why?
no
Adding would be like
adding.
Why adding?
Just can
Add.
remove card link side.
So basically
could do-
cost will be dependent on area, right?
Yeah.
Right. So area basically what matters is whatever area that car takes. Right. So what we'll do is we'll create another variable that is area, and that will replace both car length and car width. Do you understand?
It can also
Here
depend
actually
upon
we are like interpreting that car length and car width, like we could multiply and we could get another like area.
Right.
But more of the cases we could not like interpret this that way.
Right.
In that case, what
Next
we
week,
do?
now next week, right? I don't know why most of you couldn't see this particular the highest value in this table. That is what highest correlation is between what and what variables.
mileage, highway mileage and like city mileage.
Right. So there's a very highly correlated. What does it mean? What does this mean?
That means if one changes, then it will affect another. Means,
Right. So that is very obvious also, right? So city mileage and city mileage and highway mileage, right? Both will be on similar lines only, right?
Yeah.
So that means we can create a new variable mileage out of them that will replace both of them. Now here what should we do? Should we multiply them or what should we do? Add them or subtract
Adding
them?
would be, I guess,
take the average.
Yeah, we can add.
add them or take a average. Yeah.
Yeah. So one more step. Can I take one more step to it? Right. I understand it. We should be adding it or taking the average. What is the average? Average is basically equal weighted sum of both the variables, right? City mileage and highway mileage. But do we drive more cars in city or highways?
In cities, like
Right.
we
So
did.
can we use that information here? How do we
We can give more weight to the
Okay.
city
Yeah, we can drop highway mileage like.
not drop highway mileage, but we can reduce its weight, right? What you guys are suggesting, 0. Average, right? That means 0.5. Average means this, right? 0.5 into city mileage plus 0.5 into highway, right? But I'm saying that we don't drive equal kilometers or equal distances in both city and highway, right? Mostly highways are basically when you go from one big city to another big city, right? So mostly inside a city, people drive cars. So I should take what? So maybe I can give less weightage to this and more weightage to this. I can do something like this and create a new value and create a new mileage, right? I'm just writing it in not in proper syntax, just formula. Okay. So mileage is equal to, or maybe I can keep, right? It's based upon your call, right? You can keep it like this also, right? And what you guys were suggesting was this 0.5. That's what average is. 0.5 into city plus 0.5 into highway. Okay. So what I will do is I'll try to create another variable mileage that takes both of these. Okay. Does that make sense, guys?
Yeah.
So I want everyone to be participative. If you are not able to follow or you are it's difficult for you, let me know. If there's some smart decisions or these things that will come through practice, I understand, but you should participate. You should just speak whatever comes to your mind, just speak it out or write it out or chat.
Can we introduce this new mileage thing with with a proportion of like its correlation with price, like correlation of car city mileage and highway mileage with the price?
Yeah, that is also a very good thing to do, but these are very
Yeah.
similar only, 0.69 and 0.7. But yeah, and why it makes less sense, because that is something different, right? This value 0.69, 0.7 tell us that how much this is impacting our price, right? And what we are trying to do here is we are trying to take the mileage, a mileage across the complete car durations, right? Either it's a city or highway. Basically a representation for all the travels, or all the travels that that particular car had, right? Whereas if you take this, see these values and take these values as the weights, this is something different. Okay. Now next comes, now with this you got some understanding, right? Some variables set, but still all the multicollinearity, I don't think all the multicollinearity is gone, right? Too much are there, right? So what is other thing that helps us in ruling out this, or tackling this multicollinearity? Anything that you have learned in your courses?
PCI, I think,
Sorry.
VIF, we can use
Prin-
VIF for
Yeah,
principal
right.
component.
VIF is full form is,
variance inflation factor.
yeah, various inflation factor, right? So we'll be using various inflation factor further to tackle this particular problem of multicollinearity, right? So I'll just go ahead. And have you guys done any problem where you have done VIF analysis? Any problems earlier?
No, actually, like,
Okay, so this is your first project session, right?
Yes.
Okay. So this is what we have done. So we have created a new variable, car area and mileage, right? As we discussed, removing multicollinear features. Now, next thing is to do the VIF analysis. And VIF is directly, you can use the stats library from stats models, and you can call this various inflation factor function and do the VIF calculations. And this is an important step, because see, anything that you do with ED, or anything that deals with merging the variables or removing the variables or adding a new variable, that should be properly thought out decision, because it will further impact your decisions levels when you go for models, right? So any variable is not just a variable, right? It involves too many things. You have to collect the data at the source, right? You have to collect the information also every time you do predictions, right? That has a cost related to it. That maybe that is coming through some sensor, right? In this problem, nothing is coming from a sensor, but in some problems that involves IoT, that particular variable may be coming from some sensor, right? If your analysis can tell us that this particular variable is not needed, maybe you are saving the cost of that sensor. Do you get my point? What I'm trying to say?
Yes.
Right. So it's not just that about the prediction. When you tackle the data science problem from end to end, from the business perspective, there's so many things, so many aspects to a variable, right? That's why our EDA and all this analysis takes 80% or 70% of time, and modeling and everything deployment takes 30% of time, right? So all data science problem, that is common across industry. Okay, so we'll call this particular calculate VIF function. And
Paras, is there any particular way to come up with a like ratio like 0.6 and 0.4, or it's just our case.
It's just an intuition, right? There is no
Yeah.
particular way we can come up. It's just an intuition, right? We just want to give a high weightage to city mileage. That's it. Okay.
Yeah. Okay. Yeah.
Okay.
Does
So-
these assumptions will like impact our power final output?
Sorry.
Does this assumptions will impact our final output?
Yes,
Which,
sometimes like it depends, right? You cannot straight away say that based on the present knowledge, present situation. That means whatever information that we have so far shouldn't matter much, but you never know, right? What once you come up with your model, and once you see the different feature importance, right? When you do when you have deal with some regularization concepts, right? You might come up with something else, right? You might get some more insights or some more intuitions, right? But it's a small thing, right? Based upon our common sense, we can understand that this is a small thing. So yeah, either take 0.7 or 0.3, it will not, the final accuracy of the final model prediction will not matter much, right?
okay, got it.
So going ahead,
So what about curve weight and car length? Like they are very much highly correlated rather than this car length and car width.
sorry,
Curve weight
curve
and
weight and
car length. Car length.
curve weight and car length. So you are saying that they are very much correlated. Yeah, 0.84, 0.87, right? So, but straight away, like whatever based on our domain knowledge, whatever understanding, we could process these two columns only, right?
Okay.
Or these two. But rest will coming through the VIF analysis. We'll try to rule out or do something for this analysis.
Okay. So we can't do similar thing. in
That's
this-
simply can't do, right? So we don't even like get. We don't even know what curve weight is, right? With the
Okay.
definition. So does the definition help us? The weight of car without occupants or baggage. That is curve weight. And if you see the curve weights graph, there is curve weight, compression ratio, stroke, bore ratio, engine size. This is curve weight. Okay. So see, if you see the graph, this wheelbase, car length, car width, car height, and then curve weight. Even this weight difference is also not too much, right? It's very around 7.8 or then 7.6 to 7.8. It's highly dense in between that only, right? Not too much variations are there in the car weights, right? And variations are not there in a particular variable, that means it has very less impact, right? We'll see in VIF analysis whether the same kind of information is coming from there also or not. Okay. Right. So see, the motive of this complete exercise is not to come up with the right kind of decisions for you, but to make you understand that decisions are to be taken like this, right? Maybe I can, but whatever decisions that I have taken in my code or in my approach, these decisions are very bad. But this might be bad. We might need to improve those decisions. But these are the steps that we need to take those decisions. That's what something we're trying to learn here, right? Not the actual thing that these are the things that we'll have to do every time. Okay, there's no fixed steps that you'll carry out and you'll just get a 90% accuracy, right? So we'll calculate a VIF. So which two columns I should ignore immediately to calculate VIF? Which two columns I should not take into account for calculating VIF?
Column ID symbolic.
Car ID and symbolic. Okay. What else?
Peak RPM and compression ratio and stroke.
Why are you ignoring symbolic and peak RPM and why are you ignoring them?
peak RPM, I guess, like the correlation between price and peak RPM is coming around 0.085
Correlation between peak RPM and
and price.
price is 0.085.
Yeah.
Okay. So you made that I can include since this that way you will have the you this is a very heuristic way. This correlation analysis doesn't give us the right answer, right? It just it just helps us to understand uh, some information from our variables, right? So what we'll do is we'll take this peak RPM into our VIF analysis and see what happens after that, right? But there are two variables which should not be taken into the VIF analysis also. One is car ID, obviously, right? Other is
Price.
price, right? Why everyone was not able to give this answer? Is everyone in sync, right? We should not include price. Guys, please speak. Please respond.
Yes.
Yes.
Right. So we are with this VF analysis, whatever we are doing, we'll be doing only dependent variables, right? That's why we'll ignore this price thing. And other thing is that car ID is, as I told you, right? Car ID is just an observation ID. It has nothing to do with the price. So what I'll do is I'll get the VIF for everything except car ID and price. Wait, maybe I'm not on it. Okay. Now what I have with this VIF, any inferences that you can draw from this VIF table?
Yeah, I think most of them have more than 10, and like it's also infinity. Like,
Right. So most of them have 10, right? And another thing is that okay, we'll ignore it later on. So there is some work needs to be done here, right? That you all agree, right? Some work needs to be done here that can help us to come up with VIF less than 10. Right? That's what our intention is, right? Now, first thing I'll do is I'll take. First thing I will do is I'll remove what all I should remove from my analysis. Guys, what all I should remove based upon these two steps, these two rows, these two lines. What I shall remove from this way of analysis apart from car ID and price?
width and length.
Car length and car width.
Yeah, car length I should not take into account because I have taken car area, right? So there is no point in taking car length and car width.
City MPG and highway MPG.
And city MPG and okay. So now if I run this analysis again, what do I get? Right. So I have somewhat a better picture now. Right? Can you see that? Now what else I should do? What else I should do? See this car area and wheelbase. Car area and wheelbase. They have like on a similar range or they have values of even car height also, right? So can you do something around that? If you are able to recall your VIF concepts.
Yeah, we can just select those three and check their VIF.
Yes. So what I'll do is, so if I so wheelbase and car area, they have a correlation, right? So what I'll go do there is I'll just get this data set correlation graph again. Now see what happens. So you have this car area here and mileage here, right? So what we're trying to do, we will trying to see with wheelbase and car area. So see, car area and wheelbase are very strongly correlated, right? But let's see which one of them impacts the car area more. Sorry, the price more. Which one of them impacts the price area more? This is my wheelbase impact
Car
on
area.
price, and this is car area impact on price, right?
Yeah, car
It's
area.
car area, but it's not that significant. Like
So this
Car
car
area
area,
affects
that is
0.74.
another thing. So it might be the case that although we have combined length and breadth, right, to come up with the car area, but it might be the case that even car area itself is not that irrelevant, right? So what we'll do, we'll try to ignore one of them. So wheelbase we can ignore, right? That is for sure, right? If we have car area, wheelbase can be ignored straight away. Am I right, Rohan?
Could you explain that?
So what I'm saying is, so you have this correlation analysis again, right, with the car area included and mileage included like this. Now, and with this VF analysis, we are seeing that wheelbase and what next? Wheelbase and car area have similar kind of here. Wheelbase and car area have similar kind of VF values. So we come here and we check their correlations, right? And this is they are substantially high. So car area and wheelbase 0.89. Okay, and we should ignore either of them, right? We should ignore either of them. So then we check for checking which one we should ignore. We check their impact on the price values, right? Now if we check the impact of the price values, wheelbase has around 0.54, sorry, 0.58, and car area has 0.74, right? So it is safe to remove the wheelbase from our analysis, VF analysis, right? Am I clear?
Yeah.
Right. So what I'll do is that I'll remove wheelbase, right, and then run it. Next, what do you think? What should we be doing?
Car height and car area.
Car height and car area, right? They are similar. So again, we'll go. Car height is this. So car height and car area. This is car area, and this is car height. So they're our analysis says that this correlation graph says that the relations are not that high, right? So we'll have to do something else. Paste the graph, not pasting. Okay, I'll paste it. Yes, I have pasted it there. So now we removed wheelbase, we removed highway, MPG, and now we were saying that we were analyzing car area and curve weight, right? Car and car height, right? There is no strong correlation. What else? What other variables we should pick?
I think we can go for
So if
curve
we,
weight and
but if we try
correlation.
here, if I just try here and remove car height, then we have some correlation with curve weight as well as car area. Right. So now coming back to this particular graph, we'll do this again. So every time you have to do this calculations again, right? Once you have this updated, basically they updated by mileage and car area. So next is we had what else we had? Curve weight. So curve weight, see curve weight is highly correlated with car area, right? So can we ignore either of them? Can we ignore either of them, guys?
Could you explain?
Yeah, we can ignore car area, I think.
Right. So see, what I'm doing is I'm just doing the repeat exercise again and again. Right. What I'm saying is that based upon this table, our curve weight and car area are on similar PF values. And now I come to this graph and see curve weight and car area. These are very correlated with each other. Right. And now one of them we should remove. Now which one will you remove? Which has less impact on
Price,
Price.
price.
Yeah.
And which one has less impact on price?
car area.
Car area. So now you see, and difference is huge, right? So 0.10, it's 0.84 and 0.74, right? So although we had taken this car width and car length and create a new variable car area, but that is not needed, right? As per our present understanding and present analysis, right? So what we'll do is that we'll again add car area to it. Is it getting complicated, guys? Right. So this is the exercise that you'll have to do, and finally, after doing this exercise, finally you'll be left with 3 particular columns, right? So in the interest of time, I'm not going through the complete exercise, but the same exercise has to be repeated, and finally you will come up with these 3 columns. These 3 variables are there that are not dependent on each other, right? And that impact our price values: engine size, compression ratio, and mileage, right? Based upon our VIF analysis.
So what's like your like the limit for VIF that you have done?
So 10.
Okay.
10. I have to bring all these values under 10. Right? That was my goal. Okay. So now these 3 are our variables. Is everyone in following me, or any doubts, anyone? It might seem complicated because you are doing it, we are applying it for the first time. But as you apply it to other projects and as you go through this data set on your own, right, you'll get an understanding. Any doubts, anyone? Bhanu Pratap, any doubts? Rajat, are you following?
Yes, I'm following.
Okay, Himanshu, I think I have interacted with Himanshu, Rajat, and I don't know, Rohan also, I think.
What's the price mean column?
What's the price of?
Price mean. There is a column named price mean.
Right. So what I think I forgot one step in between. Yeah, so there is some steps I missed running.
So like, can you just express your idea of what price
Yeah,
means?
so the idea there is it's basically data cleaning process that was done. What was done there was, so see, we have so many names, right? Car names, right? For each car name, there was a price associated to each of them. So what a variable was created, right? A variable was created that took the mean of the mean of the price of the cars in that particular category.
I
Right?
mean, for
Let
that
me,
particular car name.
yeah. Let me run that particular piece of code. I think it's so far it has not been right. It's mistakenly there. I'll just copy it again. I think I used this wrong one. So this should be, yeah. So that cleaning part comes later on. So this is what, so I've removed everything. So this is what finally I have. Company, category.
Paras, I have a question.
Yeah.
Finally, you have these three features left, right? So
Right.
from the initial set of graphs, we can still conclude that compression ratio does not have a good relationship with price. So we can even eliminate that as well, right? Can't we?
No. So basically, what is happening? So compression ratio has no direct correlation with that. So compression, like combining this VIF and correlation analysis, right?
Yeah.
So we can conclude, we can come up with an understanding that compression ratio depends on price, no, but not directly, right? Compression ratio has some relation with other variables that we have removed, right? Which were depending on price. You
Okay.
understand?
Okay. Got it. Got it. Yeah.
Right. So now we have these three numerical features: engine size, compression ratio, and mileage, right? And someone asked what price mean, so we'll come back to this price mean again, right? I'm not sure who asked that, so we'll come back to this price mean again.
Yeah,
Okay.
okay.
So these are the final level numerical features. I'll just copy on your doc. Right now, another variable that is there with us, that is car name, right? And if we see the unique values of car name, what do you see? Any inferences with these values you can make, or anything that is visible to you with this car name?
It doesn't look like that car name can impact model performance in any way.
Yes, that is for sure. But uh, all cars have some, these car names directly will not have, but these cars have some intrinsic properties, right?
Yeah, there are some groups.
Right, there are some groups, right? So Nissan has different models, like Nissan Latio, Nissan Titan, Nissan Leaf, Nissan Juke, right? So can we take Nissan as a group, and that impacts our price?
Right, maybe.
So that's what
Yeah,
the
that
price
can
mean.
work.
Sorry.
So that's what is the price mean, like
Right.
price.
Yes. Price mean of that particular group of
Car. Yeah.
car company, you can say. Is it clear now?
Yeah.
So what we'll do, we'll club each of these, right? See, Honda has so many models, right? What we'll do, we'll combine the different models of Honda and come up and put them in one category. Okay. Is it clear to everyone? Priyanshi, are you following?
Yes.
Okay. Some are very silent. Sanchita? Are you there? Okay. Okay, Sanchita. Thank you. And what about Smruti Ranjan?
Yeah, I'm there. Yeah,
Okay.
I've been speaking. So.
Okay. Okay. And who else has not spoken? So Himanshu, I have you because I have not recognized your voices.
Yeah, following. I'm following.
Okay. Cool. So next step we have to do is we have to do some analysis, some data cleaning with respect to the car name and come up with a company name. Okay, Shubham. Okay, Shubhal. Sorry. Okay, Shubhal. Thank you. Thanks for the confirmation. If you guys have any doubt, please jump in.
So Paras, like I have one doubt. So we're actually grouping by the company name. So it might possible like for a specific company name, there might be like a higher end car versions and lower end car versions. Means they might be producing the luxurious category and like standard category.
All right. That is, I think that is very genuine doubt. So for that, what we can do is we have identified different cars, right? So Toyota has 32 cars in our data set. Nissan has 18 cars. What we can do is we can check the distribution for Toyota, Nissan, and Mazda, right? Mean, max for the prices, right? If that analysis, if that based upon that analysis, we agree that something else needs to be done for price, we should do that. Okay, so that is one more step that you can add, right? While working, you can add, you can basically process each of these company names such that basically into different categories, right? And some of these steps we will be doing also, right? What we'll do is that we will not create too many car or price levels, right? We'll create two price levels. One is high end, one is low end, right? Did that answer your question? So what I'm saying is that there are so many price levels, so many budget levels, budget at different budget levels. Companies produce cars. We will not take all the budgets from 6 lakhs to 30 lakhs, but we'll divide them in two categories. One is a low level car, one is high level car, a low end car or high end cars.
Okay, then how will do that?
Yeah,
Price is given to
we'll come to that. We'll come to that. Right. So this is clear now. So I think this data frame processing everyone is now aware of, right? How it is done. So replacing this Toyota, this is basically cleaning, right? Volkswagen was there with different names. So this they were corrected, and then Toyota was there with this name also. It was corrected. So this is something that was seen in this data and was corrected again. Okay. So now and other thing is that one more step, right, that I usually do whatever data things that I have. So whatever project I'm working on, I usually merge the very less occurring values, like Mercury and Renault. These are very low values, right? What I'll do is either I'll remove them or I'll merge them with something else, right? This is one step, right? There's so many steps out there that you do based upon different scenarios, and some might work in one case, some might not be, and those same things might not work in other case. So and maybe you followed a different approach of your data cleaning and data processing and data transformation, and I followed a different approach, but both of them come up with the same accuracy. So all those things are possible. But yeah, we can do a limited amount of steps in a 2-hour session. So you can try, you can play around, you can merge these company names into some other, because these are very less, right? One or two records are there, right? Or you could directly remove them also. Okay. So now what I'll do is I'll check the categorical columns that we have. Numericals we are done, right? Now categorical columns we'll check. And for different categorical columns, we'll plot I hope I didn't paste the code for you guys. Okay, I'll paste it. Okay, so now we have the graph generated for all the categorical columns. Now, this is where our common sense and intuitions will come now again. So now we have car names, right? And their frequency. This is for now relevant to us. Now next comes diesel and fuel, right? So our fuel type, diesel and two fuel types are there, diesel and gas. But if you see, diesel values are very less, right? Diesel values are very less, right? If you have to check, you can. How do you check? If you have to check the actual values, how do I check? You guys know any functions? If I have to check what is the actual, how many times diesel is coming as fuel type in this in our data set?
Value counts is the
counts.
Value counts, right?
Yeah.
Right.
Yeah.
So long value counts, right? So what I can do is,
Series dot value counts.
yeah. So our series will be data set and fuel type dot value counts. What is that mistake? Spelling of fuel type is okay. There is no underscore here. Right. So there, see, 185 values of gas and 20 values of diesel. So that means most of our data is gas related only, right? So we can like if it would have been less than 10, I would have simply removed that, because fuel type is not that common in our data set, and we could get away with that. Whenever we have something like this, that means this diesel is not that much of a concern for our form statement, right? Next comes aspiration counts. So there are some domain specific things, standard and turbo, and door number counts, 4 doors and 2 doors. Then car body counts, right? So Wagoner, sedan and hatchback and convertible. Drive wheel counts. See, this now, if I talk about engine location, see, engine location is again something that is very less. One value is very high front, right? So rear was 3. So what I'll do, I'll remove this 3. I'll remove all the rows which have engine location value as what, guys?
Rear.
Rear,
So
right?
in a way, should we remove the column only because all the values would be same front
Yes,
only?
yeah, makes sense. Absolutely makes sense. That is the next step that was coming to, right? So removing a column that has same value throughout, that means that column does not exist, right, for us. Yeah. So next comes engine type, then cylinder number counts, fuel system counts, then company counts, right? So each company that we have identified. See, was not something that was given to us directly. This is something, this company column we processed on our own, right? And now other problem that we have to deal with categorical column is what? We have to convert them into what? All these columns need some processing. Do you agree?
Yeah.
We cannot directly pass this FWD, RWD, and OWD to our model, right? There needs to be some processing. We need to convert this data to something so that it is understandable by our model. Right? What should we do? What is the next step?
Hot encoding.
Yes. So should I do hot encoding for everything? Just go through this data and tell me what all columns should be doing hot encoding and what all should be done to some other columns. Like for this, see this case, right? Do we need to create like hot encoding? At the end, we create zeros and ones only. What does hot encoding do? Anyone? What does hot encoding do? It creates zeros and ones,
Create
right?
a dummy variable.
Dummy variables, right? So if we have two things, if we have two columns only or two values only, 4 and 2, that means what we can do? We can create
0.
0, 1, right, for them. Does that make sense?
Yeah,
Right? We can directly replace these values 4 as 0 and 2 as 1.
Yeah.
Right? Am I clear, everyone? Prashant Bhardwaj? Venkat, Shweta, are you there? Shweta, are you there? Okay, are you following, Shweta? Any doubts? Okay. So,
What should be done in case of multiple categories?
yes.
Multiple categories. Like if we have a large
So we'll
number
create, whenever there are multiple values in a column, we'll go for dummies. We'll go for dummy creations, right? And that essentially is creating one hot encodings, right?
I mean, if it's large,
The voice is
large,
garbage.
Okay, so I'm saying if there are a large number of such categories, suppose like 30 or something, so we can do hot encoding for all those, right?
Right. So yeah. So whenever there is a very large number, maybe like 2,000 or 3,000, then the problems becomes very difficult. Like it's a different research topic itself, right? Whenever we have a very high cardinality in a particular column, right? What should we do? That's a different research topic altogether, right? Different people have to come up with different areas, different solutions. But for now, for all commercial purposes, what we do, we try to remove some of these columns to an extent that we can. We try to club some of them, right? We try to ignore some of them. So all these steps we do. Then at the end, maybe we try to use principal component analysis (PCA) to compress all those columns that we have, right? All those things we do. There is no straightforward way to avoid this one-hot encoding, right? So you have to come up with your tricks and your logics. Okay.
Yeah. Okay.
So we'll do this processing now. So first, before that, what we'll do, I'll copy in your document. So I have created some box plots. That box plots tell us how our values, how our basically whatever we had done for numerical columns, how our different categories are dependent on price, right? Basically a correlation analysis with respect to price, right? Of every column. Right. So with box plots, and I think you have done in your plotting wala module, you are when to take box plots and when to take scatter plots. So for here, box plots make sense because we are using categorical columns, right? Our categorical columns are there. So now with that, we get an understanding that our few outliers are also there, right? Few outliers with aspiration column, value as STD. There are few outliers with price, right? With gas, few outliers are there. Gas prices are very, very high. And then you understand this wave box plots, right? What is this green line?
Median.
median, right? And what are these black lines?
Lower quartile range, I guess.
Q1 and Q3.
Yes.
No. The Q1 or Q3 are like the blue line.
They're the extreme values.
Yeah, they're extreme values. Like beyond that outlier.
So these are this black. This basically tells us the range, right?
Yeah, yeah.
So going ahead, we are now I think we're running short of time by huge margin. And next thing we had was we try to understand the how price varies, right? What we did was we took the company name, we took the mean across that company name category, and checked this average price, right? So we saw that Jaguar cars are very expensive with respect to the Chevrolet and Plymouth and Honda, right? So this is an important thing, right? That's why company car name made sense for us to include, or the price mean we have included, right?
How we are going to deal that outliers that are shown in box plots?
Yeah. So for this particular thing, that I have not anything to handle the outliers, but you can do whatever standard techniques that you have used for handling these outliers, and the basic one is to remove that. I'm not doing anything in my this complete process.
Okay, no, I'm just asking, like, we are not using that, but in practical case, there might be, we are actually using a very fine like data structure. So
Right.
in real life, we will be facing like there will be thousands of outliers, and how will do deal that?
Right. So basically, there's a very standard answer to it, right? So it always depends upon the kind of data that you're dealing with, and what is that column is, right? So there is no strict rule that we can say that, and if there are thousands of them, then those are not outliers, right? Outliers are very low in number, right? If there are thousands of them in a data set, those are not outliers. That means there is some pattern there, and then you are not able to understand. Right? I'm not sure whether that answers your question, but the basic understanding is there is no clear-cut way to handle outliers. There are standard ways that you must have learned, right? Replacing that with mean or median or mode, or removing the row altogether, right? So all those things people do, and based upon the case to case, it's on the case to case basis. Okay.
In industry, like what things like there will be like selected methods, might be 10 or 20 methods. So which methods like in industry we will be using for removing this?
Yeah. So again, whatever methods that you have learned, right? Mean, median, mode, and then removing, and then uh, removing the column. So these are only the techniques that sometimes people take the nearest value and replace that outlier value with that, right? Or maybe sometimes people cap the values, right? For example, outer value, some values are there which are beyond 5,000, right? So we put a condition that this particular column cannot have any value greater than 5,000, right? So we cap. So basically, we put the upper limit on that particular column, right?
Okay. Yeah,
this
that
is
makes
how-
sense. Yeah.
So this is how some tricks we use. There is no like standard way to do it. It's tricks it's all tricks for handling outliers.
Okay. Okay, that makes sense.
Okay. Yeah. So I'm trying to get this price mean column. Okay, and then merging with our actual data. And then creating what I think someone was asking, high-end cars and low-end cars. So we are doing something for that. So we are putting a company category, right? So company categories tells us whether if it is less than 12,000, it's in the category 0, and it is greater than, it is between 12,000 to 24,000, it's category 1, else 2. Right? I don't know. I'm not sure who was asking that question. Who was asking that question about high and low end cars?
Yeah, I was asking.
So this is what we are doing, right? Company category there, right? So we are categorizing our companies into 3 categories based upon their price means. Does that make sense now?
Yeah, makes sense.
So now these are then this is our final data set, right? This is our final data set, and now still we don't have this data set in a form that our model can understand, right? You see so many strings here, so these all should be numbers. Am I right? Shivam, am I right? So can you pass on these strings to your model?
Paras, actually, we're passing like 0, 1, and 2 for company category. Don't you think like we are actually giving more stress on like greater than 24,000 price or something?
Greater than 24,000 price. So what do you mean? So you are saying that? Okay, so
Yeah, we are
yeah.
giving that.
So that company category ideally should be converted into one-hot encoding, right? That is, I think that's what you mean, right?
Yeah.
Right. So that should be converted into one-hot encoding, ideally, right? Because we should either pass 0 and 1, right?
Yeah.
So I'll just check how many value counts for it. Right, so zeros are 142, one is 24, and 2 is 20, 1 is 39, and 2 is 24. Right, we could merge these two also. Right, is one other way is to merge them, right? Because these two combine is still less than 0. Right, so we could, instead of creating 3 categories of cars, we could create 2 categories only, low end and high end. Right, does it make sense? Either create one-hot encodings or convert them into instead of three categories, convert to 2 categories only, high end and low end.
Okay, here in upper higher end we have only 24, but in some cases that it might possible like we have like some significant value, maybe 50 or something. Then what will do in that case?
Right, then we'll like just like we'll be doing for some of the other columns, we'll create one-hot encodings and we'll pass out to the system.
Okay, that makes sense.
Okay. So going ahead. So now we have this complete data set, and we check the correlation with price, right, of different column names that we have. So we can run that again. Where is that correlation wala code? We can run this again because we have changed our data set, our data frame, and now we check this correlation. Okay, so this is whatever transformations and whatever EDA that we had to do. Now we have to prepare our data in a form to be passed on to our model, right? So small steps that we need to do. I'll just I know that you guys might be getting late for your dinner, so I'll just finish off this till the point where the data has to be passed on to the model. Okay, so data set I'm creating another copy for the dataset that I have here, and our final dataset has 3 numerical columns and different categorical columns and their value counts. Oh, sorry, not value counts. New columns like company, category, and all. Okay. So now, if I check this fuel system, voila, column. So you see this MFI, SBFI, 4B, these are very low values, right? What we should do, we should create a new category, right? Maybe remaining, right? One category is MPFI, 2BBL, IDI, and the remaining category, summing them all of them, right? Putting all of them into a new category called remaining instead of putting them in a separate category, because their observations are very less. The number of observations for each of these fuel system category is very less, right? So all these things we usually do for our categorical columns. Someone was saying something? No? Okay. So now we will do this encoding, right? So, right, what I'm doing is fuel type. In fuel type, convert diesel into 1 and gas as 0. For aspiration, turbo as 1 and STD as 0. And then again, door number 4 as this 4 and 2 as this 2. And why I'm not converting this 4 as 0 and 2 as 1? Any guesses?
Because it's obvious, like 4 should be 4 and 2 should be 2. Right?
Why? Because it looks like two categories, but I'm treating this particular column as a numerical column, because
Numerical, yeah.
because what I'm doing here is that there is a relation, right? Two number of doors is not a category, it's that numerical value, right? 2 doors.
Yeah, ordinal.
Right, ordinal, right? Okay, so that ordinality we have to take care of. And see what.
Yeah, 2 doors mostly mean expensive cars, right?
Yeah, I'm not sure.
We can say that.
Yeah. So drive wheel, this see, forward is 0, 4WD is 0, and RWD is 1. Right. So I think it's split to like right side. I don't know. What does this drive wheel mean in car domain? And then for cylinder number, right? Cylinder number should also be converted into a numerical thing. Although it was given as a string, it was given as a categorical column, but we have, so this mechanism, we have converted it into a numerical column. This is a very important step. Many times people make mistakes in creating categorical and numerical columns, right? And in interviews also, when you go, so people don't ask you to implement linear regression and check training accuracy. What they ask you is your complete pipeline, right? Starting from the data that you had, what are the steps that you take, right? Do you have the clear understanding of categorical and continuous, right? All these things people try to understand from you when you go for interviews, right? So we have to be very smart in our approach when dealing with such problems. Okay, I think I have ran it twice. I'll create another copy. Okay, so this dataset PR is there now. And what I should next is, for all the remaining columns, I'll create dummies, right? For body, for fuel system, engine type, and car body, I'll create dummies. Okay. And one other point that I just now thought of, that even if for a company category, even if we treat that as a numerical column, it would not make much difference. Why? Can anyone tell me? Right? There's one thing, right? We can keep it as a category also, or we can keep it as numerical also. They will not. We will not be doing a much of a blunder if we keep this company category as company cat as 0, 1, 2. Why? Any guesses?
What's the question?
So the question is, someone had asked me, right? So this company gets, it is 0 for less than 12,000, 1 between 12,000 to 24,000, and then greater than 24,000 it is 2, right? So 0, 1, 2, right? So what I'm saying is that even if you don't create one-hot encodings for this and try to treat them as a numerical columns also, it will not make, we will not be doing any blunder. It's right only. Why?
Maybe because the number of
Because
observations for one
this
was
0, 1, 2, what do these represent? They represent price means, right? And its price means have a relation between them, right? Same
Yeah.
ordinal
Yeah.
thing.
Low, high, medium, or something
Yeah,
like that.
Yes, right. So there is some relation between them. There is a like same ordinal thing, right? Do you guys understand?
yeah, they're like normal.
Guys, please let me know. You guys understand?
Yeah, yeah.
Okay, right. So next is creating dummies for my other columns: car body, engine type, and fuel system, right? So after this, I create this data set we had. Now something again is left, which has string in it. And features. I take the numerical features. Those are 3 features, right? And basically, it's a list of all the features that we have. Right. Finally, these are our features: engine size, compression ratio, mileage, fuel type, acceleration, door number, drive wheel, cylinder number, company cat. Right. All this we are taking. Okay, so these are our final features that we will be taking. Some are direct, some are processed. These are processed features, right? And some are direct features. Some are categorical, some are numerical. So these are the final features that we will be passing on, right? So we are see nowhere there is a car name, right? Don't see car name here anyway, right? Nor obviously car ID will not also be there. But with the car name, what we did, we used car name as a company name, and the company name we converted them into three types of cars: low end car, like low range cars, mid range cars, and high range cars. Right. So this is how we converted and transformed the information that was provided to us to solve our business problem. Right. And that is what is needed and expected from a data scientist. Right, and then next step, what is the very first step that we do before we pass on the data to our systems? What is the first step that we do?
Split the data.
Scaling, yes.
Scaling, yeah. Oh.
Right, so all is on different scales, right? So gradient descent will not work. Have you guys done gradient descent?
Yeah.
Yeah, so gradient descent will not work properly if your features are not in the same scale. So what we'll do, we'll use that z-score or z-score normalization. Have you done? Do you know, guys know this z-score? What is that?
Yeah.
Anyone? What is z-score?
Expansion by sigma.
Yes. So basically, subtracting by mean and dividing by
Variance.
Standard deviation.
So standard deviation.
x minus mu by sigma. Right? That's what we do. So we applied this z-score to all the features that we have, right? And these are the features that we have. Okay. And this is our data set, final data set that we have. And next step is, should be next step? We should also convert our y values, since we had done in the beginning, right? We decided we'll convert our price column into log 10, right? So we will do that. And we'll get this x as this, and this is what this is the last step of our feature engineering, feature data processing, data transformations, data cleaning. This is the last step, and this is the first step of our modeling process. Right now, we'll start to create models based upon this X and this Y. Is it clear, everyone? Any doubts? And next step should be we'll convert this them into train test split, right? Train dot shape, test dot shape. So our 205 rows, 164 got into train and 41 got into test set. Do you guys know train set tester? Hello?
Yes, yes.
Yeah, so
Yeah,
I
yeah.
converted in this ratio of 80% of data is training set and 20% data is
20% is
test set,
testing.
right? So now from here onwards, my learning, I will train on this train data set and I will test my model on X test or X test and Y test, right? So you will start from here on, we'll start doing linear regression and logistic regression and bridge regression or elastic net, right? All these things you will start implementing. And this is the data that you will passing on to those models, right? And those models, you don't have to write those models from scratch. sklearn library provides those models. Okay. Any doubts? Anyone? I think we have exceeded a lot of time today. Really sorry for that, but yeah, that's how it goes sometimes. Any doubts, anyone?
No, I think we can move forward.
Yeah. So you guys are you guys ready to take this linear regression thing now only?
Yeah.
I think only one step, I guess, like fit and predict.
Right, fit and predict. 2 steps are there, right?
Yeah,
So,
2 steps.
but yeah, but then again, there are some concepts like feature importance and all, and cross validation and things are there. So I think we should not hurry up for that.
So how do we
Sorry.
go forward?
Yeah. So I'll discuss with Vikash. Right. So we could not finish that particular question in 2 hours. So maybe we can have half an hour or 1 hour session again.
Yeah, that
Time?
will be.
Sorry.
Yeah, that will be better.
Yeah, that will be better.
We have.
Yeah.
Yeah. So I'll discuss with him, and yeah, we'll be uploading that code with you.
So what is left? You can, tell us. Maybe we can try on ourselves.
Right. So now you have this. This is very good. So you have this train and test set, right? Now you have to try and start passing this data to your linear regression models. Right. So some example I can show you. So for example, it's very simple only, right? But the thing is, you have to understand. You should understand what you're doing, right? So I use a linear model library and took linear regression, right? Since you all know it's a regression problem, and we have done so many process to remove multicollinearity and all that from our data, right? We can pass on this data to our linear regression model, linear regression object, and X train and Y train. We should pass our data to we should pass our X train and Y train data to a linear regression object. This will create an basically this will create an object that will have the trained features, trained weight of linear
Hello.
regression. Yeah.
Paras, we actually already know all the code about the linear regression and polynomial as well. But if you could, share the steps that are remaining in this class, so we can try on ourselves.
then I think if you have already done it, so then I think I'll share the code with you guys and you can understand it, right? So we have to train, we have to fit and basically test and predictions, right? And you guys know close validation?
No, we haven't covered that yet.
Okay. Then if you have not covered, after you cover in the class, you can understand that cross validation thing also, right? Maybe in a couple of next classes, you will understand cross validation concept also, right? How do we cross validate our model? Okay, so I'll be sharing the complete code with you, right? And if you are stuck at any point of time or any function or any loop or any piece of code, you can reach out to me, right? So you all know my Slack ID. I'll post it here.
Where do you share the code?
Sorry,
How do you share the code?
it will be there in your portal itself. It will be there in the portal itself. Sorry, this is wrong. Yeah. So it's ignore that message.
So we have to do the prediction, or like, or do we need to extend ourselves?
Yeah, so you have to do it till prediction.
That's it, like linear regression prediction.
Yeah, not linear, just linear regression. You have to do linear regression, ridge regression,
Okay.
lasso regression, and elastic net. You have must have gone through this, right? Lasso and ridge,
Yeah, lasso and ridge. Yeah.
L1, L2, right? L1, L2 norms.
Yeah.
Right, beta, square, and beta. So all these things we have to do. So those are also there in sklearn. So you have to use those classes that are there in sklearn.
Okay.
Okay. And once code is there, so you will understand it. So ignore the previous message. Use this one. Okay. Any further doubts so far? What we have done, right? Whatever we covered in the class. So any doubts, anyone? Was it easy to understand or difficult to understand? Slow or fast? Any feedbacks on that? Okay, thank you. Usually, like in our company, is it right? So if there are no feedbacks from the customer, it is taken as a good feedback. So if you have any critical feedback, do share either with Vikas or Shubham, or sorry, Shivam and me or anyone. So that we can come up with better or an improved version of it. Okay.
Yeah, we have a mandatory feedback
Yeah,
in
yeah.
the dashboard. We need to fill it.
Yeah. Do fill it up. Whatever remarks that you have, do share. Okay. It will help you guys in having better sessions in future. Okay, so nice interacting with you guys. Any doubts, anyone? Reach out to me or Slack. I will be happy to help. Okay, thank you everyone. Thank you. Thanks for your time.
Yeah,
Thank you. Have a good night.
Same to you. Good night.